all, thanks again for joining today's webinar with us. This is Sylvie. I'm the product manager for Microsoft Sentinel Fusion. For today's session, we will start with an overview of Fusion. We will then talk about the Fusion detection with scheduled rules and some use case scenarios. Following that, we will cover how you can customize Fusion detection for your environment. Lastly, we will talk about the improvements we make to the Fusion ML model, specifically the scoring part. At the end, we will leave some time for Q&A, but please feel free to type your questions in the chat as we go, and we will respond to your questions as soon as we can. Okay, so I will start with a quick overview of Fusion. On this slide, you can see the key Microsoft Sentinel capabilities, from collecting data to detect and hunt for malicious activities, as well as investigation and response. Fusion mostly focuses on detecting the malicious activities using ML. At high level, Fusion uses graph-powered ML algorithms to correlate anomalous signals in your workspace to identify those advanced multi-stage attacks. The anomalous signals are the alerts and anomalies. Overall, how Fusion works, the process is very similar to how your security analyst manually going through each of the alerts, look at the entities and the kill chain stage to try to stitch them together and apply their analysis to try to find possible threats. However, because the alert volume is usually very high, so your SOC analyst may not have the time to go over all the suspicious signals, especially the low fidelity ones, to find the possible attacks. So from this perspective, this is exactly where machine learning can help. Fusion is basically running at cloud scale. It's going through all these anomalous signals and constantly finding the possible attacks that you might easily miss. The Fusion rule is enabled by default in Microsoft Sentinel. All the incidents triggered by Fusion are by design high severity, high fidelity, and low volume. On the right side, this is an example of the Fusion incidents within Microsoft Sentinel. Like I mentioned earlier, Fusion can correlate alerts and anomalies in your workspace. In addition to the alerts coming from Microsoft products, many of you are also using scheduled analytics tools for triggering alerts in Sentinel for monitoring the events in your environment. So there are so many things you can do with the scheduled analytics tool. So today I do want to dive into what scheduled analytics tools can be supported by Fusion, and later on Jessen will cover a few of the use cases from analyst perspective. On this slide, you can see currently we have three main categories for Fusion detection: scenario-based multi-stage attack detection, Fusion for ransomware, and Fusion for emergent threats. For the scenario-based multi-stage attack detection, there are 122 scenarios you can see in our Fusion documentation. You can see the required data connectors and the required alerts listed for each scenario. There are 9 specific analytics rules are supported as part of the scenario-based multi-stage attack detection. When it comes to Fusion for ransomware and Fusion for emergent threats, because the threat patterns are dynamically generated by our ML model every day, that means there are new ones coming up constantly. So we're not listing out all the possible threat patterns in our documentation. Currently, we have thousands of attack patterns detected by Fusion for ransomware and Fusion for emergent threats, and there are more to come. If you look at the data sources supported by Fusion for ransomware and Fusion for emergent threats, both detection categories cover scheduled rules, both built in and those created by your security analyst. So So I think that's an important part of the Fusion detection, and looking at the data processed by Fusion, a large portion of the alerts are coming from scheduled rules. So next, I'll expand on a bit about what kind of scheduled rules are supported by Fusion. Like I mentioned, there are 9 scheduled analytics rules supported by the scenario-based multi-stage attacks. Here you can see the full list of the scheduled rules supported. All of these scheduled rules can be created from the templates, except the one with a little star here, the new admin account activity thing, which was not seen historically. So for this one, you will need to find the query template from the Sentinel GitHub and create a custom analytics rule from it. So I have a quick link to the how-to guide on the bottom of the slide that you can take a look after the session. Also, I want to note that the scheduled analytics rules on the bottom, the Palo Alto threat signatures from unusual IP addresses. So this rule was recently added as a template in Sentinel. Fusion previously processed the Palo Alto raw logs, but in order to improve the detection efficiency, we decided to create the schedule rule template for processing the Palo Alto signals so Fusion can more efficiently correlate to the alerts generated from the schedule rules into incident. So if you have Palo Alto data connector enabled and you're interested in the scenarios using the Palo Alto threat signatures, please take a look at the template and enable this rule so you can leverage it for Fusion. All right, so for Fusion for ransomware and Fusion for emergent threats, as noted here, as long as the scheduled analytics rules has tactics information and include entity mapping, a Fusion model will be able to process them. From entity perspective, specifically, the model creates correlation on host, IP, and or account. So for the over 400 built-in scheduled analytics rules, usually the queries, the tactics information, and the entity mapping are already available in the templates. When you are creating active rules from the templates, you can just review the information, make modification as needed, and then you're ready to go. So these scheduled rule templates cover data sources including AWS, Checkpoint, Cisco, Palo Alto Networks, etc. If your analyst wants to write your own custom scheduled rules for triggering alerts, it's basically the same idea. If you map the entities properly, just making sure you call out to the potentially compromised IP, host, or account, and include the tactics information, Fusion can take them into consideration. One thing to note here is that Fusion does use the data table name and the alert name to understand the type of the event. For example, if you specify in the query that you're using syslog and the alert name is, for example, multiple password reset by user, then it's fairly easy for the Fusion model to understand what's the event it's processing. If you're creating scheduled rules from custom tables, make sure you name the table and the scheduled rule in a way that can represent the event type and show what's the suspicious activity you are monitoring, so the model can understand it. If you create a table called custom table and name the scheduled rule as like parsing for Fusion, the model wouldn't be able to understand what kind of event it is, right? So making sure you have the right information and include the possible event type in the alert name. So after talking about this, I want to answer one question we often get from customers. We often get asked whether Fusion can cover more of the 3P data sources and provide multi-cloud coverage. So the answer is yes. If you can bring in the data and set up proper scheduled rules, Fusion will be able to process these alerts from the scheduled rules and start to look for possible correlations and threats using all the anomalous signals in your Sentinel workspace. So now that I have covered all the basics about the schedule rules can be supported by Fusion, I will hand over to Jessen to go over some of the Fusion use cases with scheduled analytics rules. So Jessen, the floor is all yours now.
Thank you, Sylvie. Hi all, this is Jessen, and I am one of the security researchers at Microsoft. Let me know if everybody is able to see my screen.
Yeah, we can see it.
Okay, so let's quickly walk through an example of a possible attack that can be identified by Fusion if you have created the schedule rules, enabled anomalies, and connected to the Microsoft Defender for Endpoint Data Connector. Now imagine you're a SOC analyst and you see the alert suspicious system network configuration discovery triggered on your dashboard in Sentinel. Now, this is a low severity alert from MD and that looks at known tools or techniques that was used to gather information on the device. There are several operating system administration utilities that actually can be used to gather this information. Now, examples include ARP or ipconfig, nbdstat, or even route. So there may be chances that we may see some legitimate hits. Now, since this is a low severity alert, and out of the several other alerts that are coming in on an analyst dashboard, there may be a possibility that analysts may ignore or may even delay the investigation on this alert due to the priority of other high severity alerts they need to triage. Also, when such alerts are triggered independently, one of the major challenges SOC analysts face today is analyzing each alert and seeing if they're valid or suspicious out of the many alerts that needs to be analyzed. The lower tiers of a SOC are typically tasked with triaging alerts, and this is where the critical decision needs to be made as to whether alerts are worth investigating further or not. It is also at this point that automation of well-known tasks that do not require human judgment can have the most significant impact in terms of alert noise reduction. But when this alert is combined with other anomalous behavior and suspicious activities that we can see here, triggering at various stages of the kill chain, it completely changes the criticality of the incident. Now, this alert is actually filling in the gaps between the high severity alerts by providing more details on attacker tracks that we often see analysts doing manually or sometimes not identifying due to focus on the broader high severity alerts. Now, what happens if these alerts are triggered separately? How would generally an analyst investigate? Some of the steps an analyst might take would be to understand and see what other activities happen on that host or at the time of the alert. Or they may go ahead and check what other alerts triggered on that host. They may even want to check if the account is part of a privilege or any admin groups. And if they want to do a deeper log analysis investigation, they may run some process create log queries or run the login type events of 4625, looking at logon type 2, interact to locally, logon type 3, network logon, or logon type 10, remote interact to logon. And lastly, they may even want to check the past analyst notes, which sometimes we miss in their ticketing system to see if this machine or this account was compromised before, or if we had any history on this. So in all, we have 4 different manual steps of host analysis review, user account review, alert review, and ticketing system review that analysts may have to perform to investigate some of these alerts. And oftentimes, while investigating any incident, security analysts generally start with a single alert, then they run multiple queries to gather related alerts and anomalies, and then they manually associate those alerts and activities with the kill chain to form a complete picture. Now, Fusion's ML algorithm actually is taking care of all these manual steps and correlations, making it really easy for us to find needle in the haystack. So let's take a look at some of the general steps we can take as an analyst when a Fusion alert triggers. So as we can see here, the Sentinel incident page lets you know how many incidents you have and whether they're new, active, or closed. It shows the status. Now for each incident, you can see the time it occurred and the status of the incident. So if you're actively investigating an incident, it is a pretty good idea to set the incident status to active until you close it. Incidents can also be assigned to a specific user or to a group. Now on this incident page, if we click on investigate, it will take us to an investigation graph page. Now, investigation graph, it enables analysts to ask the right question for each investigations. The investigation graph, it also helps us to understand the scope and identify the root cause of a potential security threat by correlating the data along with any involved entities. You can even do a deep dive and investigate any entity presented in the graph by selecting it and choosing it between various expansion options. So in all, the investigation graph provides us with like a live visual context from raw data. Now the live visual graph, it displays the entity relationship, which is really important, and it's extracted from raw data, and it also enables us to easily see the connections across various data sources. It also helps us with the full investigation scope discovery. So we can expand through the investigation scope using built-in exploration queries to surface the full scope of a breach. We can also see the built-in investigation steps. We can use the predefined exploration options to make sure we're really asking the right questions in the face of a threat. So overall, the graph provides an illustrative map of the entities directly connected to the alert and each resource connected further. Now, one small thing I would also like to note is there is also an option of adding comments on the incidents as well. Comments are pretty simple to use. You access them through the comments tab on the incident details page. And as a security analyst, when investigating an incident, we may want to thoroughly document the steps we take, both to not only ensure accurate reporting to the management, but also to enable seamless cooperation and collaboration amongst coworkers. Another important thing that we can do with comments is enrich the incident automatically. So when we run a playbook on an incident that fetches relevant information from external sources, let's say VirusTotal, you can have the playbook place the external sources response along with any other information you define in the incident's comments. So to summarize on the incident, we have some pretty good evidence of a threat actor obtaining access to an account with sufficient high privilege. Now, what that means is the threat actor can now authenticate as application of service principal using this credential. We also saw anomalous user app and UBA activity as well. Then we saw the PowerShell activity that actually can be used for installation, exploration, and in some cases, lateral movement activities that's used by attackers to invoke modules, download external payloads. And we also saw process tampering, and we also saw attackers trying to gather information, or what we call as discovery activity, on the target network. And last, but the most important part, was the attackers trying to obtain domain information and the presence of AD tool that can be used for gathering information from Active Directory. So at this point, we have a pretty good picture of what has happened and how this high severity fusion incident helped us pivot through the kill chain stages of some suspicious attacker activities without taking much manual step. Now, let's take a look at second example that's related to Linux-based attack. Now, here we're using schedule alerts built in on syslog data and Azure Security Center. That's what the scenario is based on. So in this example, let's assume that an analyst sees this Microsoft Defender for Cloud alert, and the alert is possible crypto coin miner download detected in Sentinel. Now, it's pretty evident that this machine is actually used for digital currency mining activities. But the question from a SOC analyst perspective would be, well, how did the attacker get in? What activities did they perform? Is the activity only limited to digital currency mining, or is there more to it? So now here's a summary of an attacker activity. We can see how this single fusion incident, it has revealed attacker tracks right from reconnaissance stage to detecting suspicious shell scripts that's actually used to download attacker payload, along with triggering on digital currency mining activities. The one thing we have seen pretty often in these crypto mining campaigns is how attackers, in order to get the maximum CPU usage and efficiency, they try focusing on deploying new instances of mining payload. And generally after this activity, the traces of cryptocurrency wallets or other activities related to mining becomes pretty evident. And generally the next step attackers do is they will try to evade detections by deleting the tracks. The good thing is all these activities are aligned and shared in one fusion incident through alerts that are detecting such activities. Now, in both these examples, we saw how a single fusion incident can save so much time and help in impactfully reducing the alert fatigue, which is a really big challenge faced by every SOC. It also revealed a high fidelity alert, and it's also including products in the security ecosystem to work together. Fusion also helped in automating the initial analysis work for defenders while investigating an attack, and start from a tier 2 level of analysis, thus helping SOC teams reduce the mean time to detect an attack and respond. SOC teams now will be able to really focus on active, proactive hunting instead of repetitive incident response activities. In these examples, we also saw references to schedule alerts as well. So for Fusion to work really well, there are a couple of things that I would like to quickly point out related to schedule alerts that's important for Fusion correlation engine to work well. So the first thing I would like to talk about is the MITRE attack and tactics and techniques. Now, from the Sentinel navigation menu, if we select the analytics, we can see there is the schedule query. And if we click on edit, it will take us to a page that has columns of name, description, severity, tactics, and techniques. Now, it's really important that we add the right MITRE attack tactics and techniques here so that Fusion's ML model can map the alerts with various kill chain stages, along with the severity, to develop potentially the right sequence of the attack. Along with that, it is also important that to do the entity mapping as well. So if we select the select rule logic here, it will take us to a page of entity mapping. As we can see here, entity mapping is not only an integral part of the configuration for schedule query analytics rule, but it also plays a big role in Fusion. It enriches the rules output, generally alerts and incidents with essential information like IP user account or host, which does serve as a building blocks for Fusion to connect the dots. So with that, this concludes the Fusion scenario part. And now I will pass it on to Cristhofer to walk us through the customizable Fusion part.
Excellent, excellent. Thank you, Jessen and both Sylvie, for the great comprehensive demonstration on how Fusion actually works, the different data sources that we currently actually support, and then, of course, the different attack scenarios that we take into account, right? Both anomalies, schedules, rules, and the different third-party data sources that are also included. In the chat, there was a couple of questions regarding, whether or not Fusion is enabled out of the box. The answer is yes. So there will be a analytic called Advanced Multi-Stage Attack Detection. That is the Fusion analytic rule that is enabled out of the box when you enable your Microsoft Sentinel solution. And we'll just walk through quickly how you're able to customize Fusion, right? So after Fusion actually gives you alerts, you're able to, digest incidents from Fusion. How can you actually give your own custom input when it comes to the source signals that are taken into account when it comes to Fusion? So again, Fusion correlation engine, is a scalable machine learning algorithm that really allows you to detect those different incidents or attacks that may have gone undetected. The great thing about Fusion is that Fusion is actually sprinkled all over the Microsoft Sentinel portal, right? It's everywhere, and it is definitely a very key component to be able to satisfy both the alert fatigue and also false positives as well. When it comes to customizing Fusion, there's a couple of different entry points. One of them is the Fusion configuration UI. This is where you have the ability to actually edit the advanced multi-stage attack detection rule. And from there, you are able to configure the source signals for the Fusion detection. Now, there's both a input and also a output out of Fusion. This right here just shows you a quick screenshot of what it looks like to actually have the ability to include and also exclude these different sources based off severity, also based off the different data sources. When it comes to the Fusion configuration UI, you do have the ability to actually define the scope that is defined and monitored by Fusion. On top of that, something very critical is actually excluding specific detection patterns that may not be applicable to your environment. So again, we do have a scalable machine learning that is working to give you high fidelity and high accuracy when it comes to the incidents that are being generated by Microsoft Sentinel Fusion. However, right, there may be a Fusion specific detection pattern that may be noisy or may be prone to false positives, or maybe it just doesn't apply to your environment. And this is where you actually have the ability to exclude a specific detection pattern from the Microsoft Sentinel Fusion. So again, there's lots of flexibility here when it comes to actually providing, your own custom input based off your own custom needs for your security operations. So if we continue here, just quickly, just want to show you more of what it looks like to actually configure the source signals. Again, you do have the ability to configure the different sources, both anomalies and also the alert providers. And you also have the ability to include or exclude the severity levels. Just here on the right hand side, I do have two different use cases in which you may want to exclude signal sources from Fusion. One of them is if you're actually testing a specific signal source known to produce noisy alerts, you can temporarily turn it off. So at the end of the day, you do have that trial sort of flexibility when it comes to Fusion. On top of that is actually configuring a alert severity for each provider, right? So imagine if you have a SOC and you have a separate process for triaging high severity alerts, and you would not prefer to have these alerts included in Fusion, you can actually exclude the high severity alerts from the Fusion detection. So again, lots of flexibility, allowing you to have your own custom input when it comes to your own custom needs as part of your own security operation strategy. When it comes to excluding these specific detection patterns, is very critical for you to understand that aside from a Fusion detection not being applicable to your environment, or it being prone to generating false positives, the great thing about it is that once you actually exclude a detection pattern, the detection pattern will still trigger, but it will not show up in your active incidents queue, right? It will just actually show up. It will automatically close it out for you, right? So at the end of the day, we're still triggering it, but we're closing it for you automatically since you do want to exclude that specific detection pattern. This right here just shows you a quick screenshot of what a Fusion incident looks like. And this is a Fusion incident that actually covers possible multi-stage attack activities. As you can see here under the timeline, we do have a scheduled analytic rule, which is a distributed password cracking attempt in Azure AD. And here at the bottom, we have the anomaly. This is a anomalous Azure AD signing sessions. The reason why anomalies are so critical, not just for Microsoft Sentinel, but any security operations strategy, is that at the end of the day, you want to have a behavioral profile that gives you a sense of what's normal, and then from there alerts you whenever we have a deviation when it comes to that when it comes to that behavioral profile. The reason why that is so paramount, especially in today's cybersecurity landscape, is because as a SOC analyst, tier 1, tier 2, you want to have the ability to have more context and more insight when it comes to both triaging, investigating, and also responding to incidents across your environment. So having those anomalies there is also very critical. Let's jump into a quick demo to show you exactly how this looks like within the Microsoft Sentinel Portal. How do we actually configure the source signals? How do we exclude the pattern detection? And then lastly, based off the anomalies, if we have a incident that includes anomalies, how do we actually fine tune it, right? Like, how do we actually configure the threshold? And also how do we configure the scheduled analytic rules as well? Here we go. Yep, so this right here is the Microsoft Sentinel Portal. Again, if you go into analytics, you're going to see that the first analytic rule that we have here as active rule is the advanced multi-stage attack detection rule. As you can see here, the rule type is Fusion. Fusion is what we do. That is the correlation engine behind it that we are able to stitch together low fidelity alerts, anomalous activity with high severity alerts, and put it all together and package it to give you a full attack timeline of what occurred. If I click on the advanced multi-stage attack detection on the right hand side here, I get more information when it comes to what Fusion is and what Fusion does. And then on top of that, the different detections that we actually support at the moment. On the bottom here, you can see edit. So when we click edit, this is going to bring up the analytics rule wizard. A lot of you are probably familiar with this UI. This is where we are able to enable and configure the analytic rules across Microsoft Sentinel. And here at the top, we have different tabs. We have General, Configure Fusion, Automated Response, and then we have Review and Update. Under Configure Fusion, this is where the power of fine-tuning, of customizing Fusion really comes in. And this is where we have the ability to configure the different source signals for Fusion detection. As you can see here, when it comes to sources, we have anomalies. We also have alert providers. Again, I can always exclude it, depending on the different use cases that we have across our security operations strategy. At the end of the day, anything that you include or exclude has to have some sort of purpose. So if I exclude Defender for Endpoint or Defender for Cloud, or maybe I only want to exclude certain severity levels, I have to have a why behind it. And what's the use case? What's the overall metric that we're trying to track across our SOC? The recommendation from Microsoft is for you to actually include all the listed source signals with all severity levels. And the reason why is because, again, the more the merrier, and that's more data that the machine learning model has to actually work with. And that can actually give you the best results when it comes to accuracy and also fidelity. When it comes to the alert providers, again, we have it ranging all the way from identity protection to Microsoft Sentinel near real-time analytic rules. On the right-hand side here, we have our severity levels. So we can actually exclude, for example, informational and only include high. So there's definitely lots of flexibility here when it comes to what we have here as part of Microsoft Sentinel Fusion. Something else that I also want to cover, and just quickly here, while I reconfigure my environment, is that when you actually look at configuring your source signals as part of Microsoft Fusion, you also may want to think about what specific detection patterns you may want to exclude, right? So after you start to digest the different incidents from Microsoft Fusion, what are some different detection patterns that are, prone to false positive or noisy? They're actually increasing the false positive rate across the security operations center. These are things that you want to take note of. And the way that you actually exclude a specific detection pattern from Fusion is by getting an incident that already has that detection pattern. So what you would do is go into incidents. Again, as part of incidents, we do have now a advanced search. So I will go under advanced search and I will select incident description. I click on apply, and then I just type in Fusion. This is going to search across all of my incidents looking for Fusion as part of the incident description. If I click on this one, for example, which is a network request to Tor anonymization, and I click on view full details, under the timeline, I am able to understand all the different, again, analytic rules, anomalies, or anomalies that are actually part of the overall attack. And we can see here that a Palo Alto threat signatures from unusual IPs analytic rule is part of the overall attack timeline. Now, let's say that this is a very noisy alert, it's not applicable. You know, we have to close it as benign positive. I can click on show more. And again, as part of the overall incident description, you do get a comprehensive abstract on how Microsoft Sentinel Fusion was able to correlate these two different analytic rules together. At the bottom, you see this new section, which is exclude this specific detection pattern. So again, the machine learning model in Fusion is trained to give you a high degree of accuracy, but depending on your own custom needs, you may need to exclude some specific detection patterns. The way to do that is by clicking on the exclusion link. When I click on the exclusion link, it brings us back to the familiar UI, which is the analytics rule wizard. And over here at the bottom, now we can see that we have our Palo Alto threat signatures from unusual IPs pattern that is currently being excluded. So this is the way on how you can configure the source signals that are taken into account by Microsoft Sentinel Fusion. And then on top of that, how you're actually able to exclude a specific detection pattern from your Fusion detection. Now, let's talk about how you are able to fine-tune incidents that may have an anomaly. And again, this is very critical because at the end of the day, you want to be able to understand exactly how this stuff works. Just give me 1 second while I try to get my other window, and we will go ahead and cover it. As you can see here, I have a brand new Sentinel incident here, and this is a possible multi-stage attack activities detected by Microsoft Sentinel or by Fusion. And we can see here that we have a medium scheduled analytic rule, and then we have a anomalous Azure AD sign-in session, right? I can go ahead and click on the anomalous Azure AD sign-in session just to better understand exactly, what is the description, what is the anomaly that we're looking at, what is the severity, what are the different entities that are part of this anomaly. And then, of course, I can get more information when it comes to the last updated time or the start time. One pretty good pivot point that you can have as part of your overall SOC is clicking on the system alert ID. When I click on the system alert ID, it actually brings me to log analytics. And as part of log analytics, I am able to see or understand more of this anomaly, right? So I can actually expand this and I can understand more around what actually occurred. If I click on the extended properties, I can understand exactly, who it was processed by, the rule name, etc. Now imagine that this is a anomaly that we may want to fine tune because again, this may be a false positive or maybe we want to increase the threshold. This is where you would go back into, let's go here. You would go back into analytics. And then under anomalies, you will paste that rule in. When you paste that rule in, you're going to see different templates that we have here. So for example, we have a anomalous Azure AD sign-in session. I can select this one. I can duplicate it. And when I duplicate it, this is where basically I am able to customize this template. So what I do here is that I click on edits. At the end of the day, similar UI, analytic rule wizard, but for an anomaly, Under mode, we have production, and then we have flighting. Under configuration, this is where I am able to customize the definition of this anomalous activity by configuring these parameters that you see here. So let's say, for example, I do not want Microsoft Sentinel to take into account the number of failed sign-ins or the distinct number of states. I can configure it, and then on top of that, I can also modify my threshold. Here under the results preview, I can actually get an estimate when it comes to, what would be the difference if I actually make this modification within the last 30 days. And if you have any sort of results, it will also show up here. That right there is how you're able to modify or fine tune the anomalies that you see as part of Microsoft Sentinel. And then on top of that, how you're able to configure the source signals and how you're able to exclude specific detection patterns as part of Microsoft Sentinel Fusion. Again, Sentinel Fusion is very, very flexible, and you're able to add your own custom input to it. With that being said, I'll pass it over to Sylvie to cover the improvements that we have made when it comes to the Fusion models.
Thanks, Christopher, for walking through the Fusion configuration and customization options. Now we'll talk about the updates we made recently to further improve the Fusion detection capability. Before I go into the specific improvements we made, I'll quickly walk through how Fusion works end-to-end. Overall, we put the anomalous signals, these are the security alerts and anomalies, into the Fusion pipeline. Run graph-powered analysis and apply probabilistic kill chain, and then generate high-fidelity incidents. On this slide, you can see how Fusion works end-to-end. Once the anomalous signals are in the Fusion pipeline, there are 4 steps that we go through: graph forming, attack pattern matching, expansion, and scoring. The first step Fusion takes here is to build a hyper-connected graph using the alerts and anomalies in your Sentinel workspace. The graph is being constantly updated as new data comes in. In the graph Fusion constructed, the nodes represent the entities and the activities, and the edge represent the relationship between the nodes. So the entities can be IP addresses, accounts, cloud resources, virtual machines, etc. The activities are the alerts and anomalies you get. For example, anomalous signing activities, suspicious manipulation of your mailbox rules, etc. So the second step here is attack pattern matching. So Fusion has a very large set of attack patterns based on the learnings from security experts and the security research within Microsoft. We also have an algorithm constantly running to find new attack patterns. I think I mentioned earlier, we have thousands of patterns generated by our model, and there are new ones being generated every day based on the continuous learning. In the example here on the screen, there are 3 attack patterns matched in the graph. So these are the orange highlighted nodes and edges, and we call each of these clusters as subgraphs. After pattern matching, Fusion expands the matched attack patterns to discover additional activities and entities that are relevant to the matched pattern. So the green nodes and edges here are the results from the expansion. So in this step, Fusion calculates relevance and run probabilistic random walk to determine how far to expand. So I'm not going to go into the details here. So we have a technical blog talking about how Fusion model works, and you can check out the blog if you want to learn more about the details. These links are included at the end of the presentation. So the last step before incident creation is scoring. Fusion applies a random scoring to decide first whether we trigger an incident. Second, which are the most relevant alerts, anomalies, or the entities to include in the incident. In the example here, the yellow colored nodes are the most relevant most relevant ones to include in an incident after scoring. So the nodes and edges remain green are currently not included in a Fusion incident to help you further reduce the noise. The goal of the last round of scoring is to really focus on the highest fidelity detections and help you speed up the investigation with the most relevant information. So with this goal in mind, our Fusion team worked on improving the scoring model and released the update a couple months ago. I'll talk a bit about the old model and the new scoring model that's currently running. So the old scoring model is heuristic based. It is an unsupervised model, and we use KNN, K nearest neighbors, to calculate the kill chain reachability. That basically includes the reachability within the subgraph. The model also looks at how likely it is to reach high value assets or the known compromised entities, as well as how likely it is to reach other potential attacks, etc. So the old scoring model is working pretty well, but we think we can make it better. So we worked on the supervised scoring model. At high level, training the supervised scoring model is basically leveraging customers' feedback, so true positives and false positives, and linking them to the broad features we have built in the model. So that includes first the tactics, severity, joint entity types, and the event type and their combinations. So the joint entity types are host, IP, and account. When it comes to event type, the model needs to understand, is this event coming from endpoint, or is it Azure activity, or is it Office activity, etc. We also consider the entropy and the diversity of the alerts and anomalies from the previous attack pattern matching and expansion steps. So with this new supervised scoring model, we are able to provide richer and more diverse score while evaluating each possible attack. So the ML algorithm is also be able to learn the patterns and better differentiate the true positives from false positives. I think in the chat earlier, there was a question on how Fusion leverages the customer feedback, and this is a new model that we're taking customer feedback into consideration. The feedback is used in other parts of the model, but for this part, it's really helps the model to learn what are the false positives we're seeing from the customer feedback, and the model will improve as it goes. So for example, if we have two very similar attack patterns that consist of basically the same set of TTPs, the difference is really the activities happened at different stages of the attack. For example, gaining access to valid accounts that happened during the initial access stage versus the privilege escalation stage. For the old model, it would give a very similar score to the two attack patterns, as the kill chain reachability would be very similar. For the new model, however, it will be able to differentiate whether the activity is more false positive prone if it happened at initial access stage versus the privilege escalation stage based on the learnings from the customer feedback and the model training. So overall, looking at the detections and the customer feedback in the recent months, we're seeing further reduction in the false positive rate, which means the new model is being pretty effective. So from this perspective, I would really encourage you to provide accurate feedback label when you close the incident. If there's additional notes that you're open to share, please feel free to include them in the incident comment. It will help us better understand the true positive and the false positives. This will definitely help us improve the model and also help you to get higher quality detections. All right, so that's it for the webinar today. We have 6 minutes left, and we can start answering some of the questions in the chat window if our team did not have time to get through all of them.
Yeah, sure. We do have a few. The first one is, are the Fusion scores updated from customer Sentinel instances in order to apply larger data sets to the fidelity?
So basically, we do the scoring based on each of the attack that we observe, and the scoring is really based on the data you have in each of the Sentinel workspace.
Great, thank you. And then I know you touched on this in the chat, but thought it was worth reiterating since we got so many upvotes. The question was, does Fusion add any additional cost to an E5 subscription?
So Fusion, this route is enabled by default within Sentinel, and enabling the Fusion route does not increase any additional cost. It really depends on the data that you are bringing into Sentinel and the schedule rules that you set up. As long as you have the data in there and you're generating alerts from Microsoft first party or from schedule rules, Fusion will be able to process them. So enabling the Fusion route does not occur additional cost.
Great, thank you. Next question we have is, in order for Fusion to work, entity mapping must be applied to analytic rules. Will Fusion still operate if the data is in a custom log?
So Fusion does not process the custom logs. So the data types supported by Fusion are alerts and anomalies. So for example, if you have syslog data in Sentinel, Fusion won't be able to process syslog directly. If you create schedule rules to basically promoting the syslog into security alerts, Fusion will be able to take these alerts into consideration.
Great, thank you. The next one we have is it correct to say that Fusion no longer looks at raw logs like Azure Active Directory sign-in, FW log, security event, etc., and instead looks only at alert signals, and those alert signals can come directly from other products like MDE, MDI, AADIP, or the alert signals can come from scheduled analytic rules?
Right, so because you can create scheduled rules for many of your raw logs, because like the raw logs, the volume is really huge and it can be very noisy. So it's not efficient for Fusion to process all the raw logs and finding correlations. If you are able to create scheduled rules for the raw logs that you're bringing into Sentinel, and there are many great out-of-the-box schedule root templates supporting various data sources that you can use. Basically, if you can enable the schedule rules for these data connectors or create your own custom rules for the data connectors, you are basically creating the alerts that Fusion can leverage.
Great, thank you. And the last one we have is, if analytical/NRT rules are created against tables that are not Microsoft provided data sources, custom log data, will the Fusion rule still aggregate alerts based off those Sentinel rules? Is this dependent on entity mapping leveraged at rule creation?
Fusion will still be able to leverage those alerts. Fusion takes many aspects into consideration while processing this type of alerts. Fusion look at the query that you're using for generating the alerts, looking at the entities, severity, kill chain mapping, and the event type, etc. We take multiple aspects into consideration while processing the alerts generated from schedule rules.
Great. Thank you so much for answering the questions. And thank you, Cristhofer, Jessen, and Sylvie for being our guests today and for an excellent presentation. At the same time, I would like to remind listeners that the best way to ensure you don't miss any future webinars or major announcements is to visit our landing page at aka.ms/securitycommunity. And while there, you'll find easy ways to navigate and find the resources and learning content relevant to our security products and their communities. A good start would be browsing our bite-sized product videos, ninja trainings, recordings of past webinars, GitHub communities, and more. We love to hear your feedback on how we can improve these webinars. Please take a minute submitting your webinar feedback at aka.ms/security webinar feedback. Thank you and see you next time. Goodbye.